So now student, we are going to discuss question number 7.20. Clear? In this question it is given to you a LCR series circuit with L equal to 0.12 Henry, C equal to 480 nanofarad and R equal to 23 ohm is connected to a 230 volt variable frequency supply. As you can see in this screen, actually I drew here already. This is series LCR circuit. We have three components: inductor, capacitor and resistor, and it is connected to a variable source, and we can say that is having VRMS 230 volt and standard. You can say you can find frequency also. Clear? So now in this question it is given number A part, what is the source frequency for which current amplitude will be maximum, and obtain the maximum value of current. Clear? Now we know when we find value of current is maximum. Clear? So if I write expression of current, we can say current, this is given by V by Z. Z we can say this is impedance of this circuit. Clear? So now we can say, if we are saying this is VRMS, this is also VRMS. Now important part, this current that is flowing, it is maximum when we can say this Z will be minimum. Clear? Now expression of Z, it is given by under root of R square plus we can say XL minus XC whole square. So this Z will be minimum when this term XL minus XC, this should be equal to 0. Clear? And this is possible only whenever we find condition of resonance. Clear? It means now we have to find source frequency. So directly you can say you will find we can say resonant frequency, and you know formula, it is given by 1 upon under root of LC. Clear to everyone? 1 upon under root of LC. So now I am writing omega R, this is equal to 1 upon under root of LC and 1 upon under root of, now what is value of L? L value is given to you 0.12 Henry. So this is 0.12 Henry and multiplied with C. Clear? Value of C is given 480 nanofarad. Clear? So I can say this is 480 into 10 to the power minus 9 farad. Clear? So now if you calculate, you can write like this: omega R, this should be equal to we can say 1 upon under root of 12 divided by 100 into 480, and we can say this is 10 to the power minus 9. Clear? I can say this one and this one cancelled out, and we can write like this: this is 10 to the power minus 1 and minus 9, and this is 10 to the power minus 1. So it becomes 10 to the power minus 10, and we can say this is equal to 10 to the power 5 divided by under root of 12 into 48. Clear to everyone? So now if you write omega R, this should be equal to 10 to the power 5 divided by, now if you multiply it, we can say 12 multiplied 48. Clear? So you can write like this: 12 multiply 50 minus 2. Clear? So now we can say this is 600 minus 24. So 10 to the power 5 divided by 600 minus 24, and we are taking square root. Clear? So from here you can say this should be equal to 10 to the power 5 under root of 576. Clear? This should be equal to 576. Clear everyone? So this is value of omega R we are getting, and we can say this is given by radian per second. Clear? Now so if you solve it, near about you will find this value 625 we have, that is 25, and 576 we have 24. Clear? So we can see omega R, this is given by 10 to the power 5 divided by 24. Clear? So if you solve it, you will find this answer near about, we can say 4176 radian per second. Clear to everyone? So this is, we can say this is resonant frequency. Clear? This is value of resonant frequency. But what is our objective? Our objective in this question is to find maximum value of current. For that one, first I will find IRMS. Clear? Or you can directly write like this: if we want to find maximum value of current, we can say this is given by V0 divided by Z. Clear? Maximum value of voltage, or we can say peak voltage, it is given by under root 2 times of VRMS. Clear? And it is divided by Z. In resonance condition, you always find capital Z is equal to capital R. Clear? So I can say this is divided with resistance. Value of resistance is given, yes, this is 23 ohm. So I can say this is 23. Clear? So from here we can see I0, this should be given by under root 2 divided by 23 multiply. What about VRMS? Clear? So VRMS, we can say VRMS, it is given by V0 and multiply under root of 2. Clear? So now we can say, we can write like this, V0 multiply 2 divide by this is 23. Clear? What is value of V0? Value of V0 we have, this is we can say, actually this is what VRMS equal to V0 into root 2. Clear? So V0 into, we can say 2 divided by 23. Clear? So can we find value of actually you know this is VRMS? Yes. So directly actually we can write like this, listen very carefully. Directly we can write like this, I0 is given by under root 2 times of VRMS upon 23. Yes. So now we can say this is under root 2 multiply VRMS. Clear? VRMS we have, this is 230 volt. So this is 230 volt and this is divided by 23. I can say this is 10 under root of 2. Clear? And this value we know, this is 10 into 1.414 and this should be equal to 14.1 ampere. Clear? 14.1 ampere. So we can say this is maximum value or peak value of current we have. Clear? So this is all about part number A. Clear to everyone? So this is all about part number A. Now second part. Second part is given what is source frequency for which average power absorbed by the current is maximum. Clear? So average power will be maximum when the current flowing in the circuit is maximum. Current will be maximum only whenever we have a resonance condition. Clear? Resonance condition means we can say omega r, this should be equal to 1 upon under root of LC. Clear? So directly you can say, we can write like this if we talk about part number B. So in part number B, we can say average power, but this is maximum power. Clear? And we can say this is given by IRMS square and multiplied with R. Clear? So now we can say IRMS we can write like this, this is I0 divided by under root 2 whole square multiplied with R. Clear? So I can say this is given by I0 square divided by 2 multiplied with R. Clear to everyone? So now we can say average power we can say it is given by I0 square. I0 value we have, this is 14.1 or you can say 10 root 2. Yes. So directly you can say 10 under root 2 whole square divided by 2 and multiplied with 23 because resistance value we have 23 ohm. Clear? So from here you can say this is 100 multiply 2 divided by 2 into 23. We can say 2 and 2, this one is cancelled out. Clear? And this is given by 2300 watt. Clear? So I can say this is maximum power. This is maximum power. We can say this is maximum power obtained. Clear? And this value we are getting 2300. Now we have to actually also write what is the source frequency for which average power is maximum. Clear? So maximum we can say source frequency at which the average power will be maximum, so that is equal to, we can say, resonant frequency. Clear? And resonant frequency value you know very well. Yes, we can say that resonant frequency is given by directly you can omega r, this is 4167 radian per second. Clear to everyone? So this is all about part number B. Now we are going to discuss for part number C. In part number C, it is given to you for which frequency of source is the power transferred to the circuit half the power at resonant frequency. Okay, and what is the current amplitude at those frequency. Clear? Now let us try to understand. Actually, what is our question? Concentrate here. For which frequency of source is the power transferred to the circuit is half of the power at resonant frequency. Clear? So I think you should have one thing in mind, that is given by omega. We can say this is given by omega r plus minus delta omega. Clear? We can also write this equation, this expression we find whenever we are getting power at half of the power that we are getting at resonant frequency. Clear? It means we can also write like this, this is f, we can say this is 2 pi, just a minute. How can we write omega? Clear? Actually you can also write like this, omega, this should be given by omega r plus minus. Clear? plus minus, and we can say this is equal to R divided by 2L. Clear? Yes. So now from here you can say, actually we know omega, it should be equal to 2 pi f. Clear? So how can we write value of f? We can write like this. If we divide by omega 2 pi both sides, we can say, we can also write like this. Yes or no? Clear to everyone? Now we can say, from here you can find this frequency in terms of f, or we can say hertz. Clear? We can say this is fr plus minus, this is equal to r by 2l, and this is 2 pi. Clear? Now actually you can also write it like this, f equal to fr plus minus. Now you can put all values. Value of r we have 23, divide by 2, multiply. What about l? Clear? What about L? L is given to you 0.12. So this is 0.12 multiply 2 multiply pi. Clear? Pi value is given to you. You can say this is 22 by 7. Clear? So now we can say, you can write like this, fr plus minus. Now you have to calculate this expression. Clear? So if you calculate it, clear, approximation you can take 23 and 22 near about, this is cancelled out, 7 is going in upward direction. Clear? 2 to 4, here we have this is 0.48. So 7 divided by 0.48 means we can say 70 by 4. Clear? 70 by 4, it will be near about. So I am directly telling you what expression you will get. You will get this expression near about 15.25. Clear? Clear to you? Yes. So, or you can say nearly you can take this value is equal to 15 hertz. Clear? Now what is value of fr? Clear? Actually we know omega r, it is given by this expression. Clear? Omega r is given by 4167 radian per second. Clear? So 4167 radian per second. We can also write it like this. This should be equal to 2 pi multiply fr. Yes or no? So from here you can say fr, this is given by 4167 divided by 2 pi. Clear? 4167 divided by 2 pi. So now I can say this is 2, 0, 8, we can say this is 3, we have 1, so this is 5, divided by, I can say this is pi. Clear? So fr value is given 2083.5 divided by 3.14. Clear? So now if you solve it, you will find this value is near about, we can say 663 hertz, near about. Clear? So from here you can say what frequency range you are getting. We can say f is given by fr plus minus, we can say this is 15. Clear? So you are getting this value 663 plus minus 15. Clear? So two frequency at which you can say power is half of the maximum. It is given by, we can say this is 876. So we can say this is 678 hertz, or we can also write it like this, 663 minus 15. Clear? So this is equal to, we can say this is 8, and we can say this is 4, and this value we have in hertz. Clear everyone? So like this we can find value of f1 and f2. Clear to you? Clear? Yes. Now at this situation, one more thing is asking to you in this question. Yes, frequency we have already find it. What is the circuit amplitude at this frequency? Clear? Which is the current amplitude? Clear? Current amplitude we actually we have to calculate current amplitude. Current amplitude is actually we can say it is given by AIIMS divided by 2. Clear? Just current amplitude. Actually you can find this current amplitude like this. We know at this frequency power is half of the maximum. Clear? And we know power is given by I square R. So directly we can say power is directly proportional to I square. It means we can say whatever I naught, that is we are getting. Clear? Or that we are getting, it is equal to under root of P. Yes or no? Clear? So from here you can say actually we are getting here I naught, this is equal to you can say this is P naught by 2. Clear? So from here you can say I naught, this is given by I naught by root 2. Clear to you? Again I am explaining what I write here. Clear? Actually we know P is directly proportional to I square. clear, or it means we can say when we have power half of the maximum power, so at the same time the current will be I can say current will be 1 by root 2 times of maximum current, clear. So directly you can say I is given by this is equal to I naught by root 2, clear to everyone. We can see why I am writing like this, because you know I square directly proportional to P. Now if we are doing half of the P, clear, at the time you can say current becomes 1 by root 2 times. That's why I am saying the maximum current becomes 1 by root 2 times of I naught, clear. So from here you can say value of I naught, you know, yes, value of I naught we know, this is given by 14.1, or you can say 10 root 2, clear. So directly we can say 10 root 2, so 10 under root 2 divide by under root 2, we can say this value we are getting, this is 10 ampere, clear to you. So at 10 ampere we can say we are getting power half of maximum power that we are getting at resonant frequency, clear. Okay, now we have one more part of this question, this is part number D. What is the Q factor of the given circuit, clear. So actually Q factor always provides to you sharpness of the circuit, clear, or we can say if you are drawing a graph how sharp that curve is, clear. So it is given by Q factor. So directly you can say Q factor, it is given by one formula, omega r L divided by R. Omega r L divided by R, omega r value we know, this is equal to we can say 4167 multiply what is value of L. Value of L we are getting, this is 0.12 Henry, clear. So 0.12 Henry divide by, now we can say this is 23, clear. So from here you can say if we remove this decimal we can write this is 100, this is near about 2, clear, this is near about 2. So we are getting this value to, we can say 083.5 and divide by 100, clear. So this value of Q factor, this value of Q factor near about we are getting, this is 21, clear. So this is all value of Q factor, clear. So this is all about this question.